Right now, at this very second, there is a place in the universe where time appears to slow to an extreme, where space is warped by gravity, and where even light cannot escape once it crosses a certain boundary. This isn't science fiction or fantasy. It's one of the most extraordinary realities in our universe. Some black holes are so massive that they contain billions of times the mass of our sun. By the end of this video, you'll understand why black holes are among the most fascinating objects ever discovered. Most people imagine a black hole as a giant vacuum cleaner in space that pulls everything toward it. In reality, that's not how they work. A black hole forms when an enormous star exhausts its fuel and collapses under its own gravity. The matter becomes compressed to an incredible degree, creating an object so dense that its gravity dramatically bends space and time. At its center lies what physicists call a singularity, a region where our current understanding of physics breaks down. Surrounding it is the event horizon, the point beyond which nothing, not even light, can escape. Once anything crosses this boundary, it can no longer communicate with the outside universe. Interestingly, Albert Einstein's own theory of general relativity predicted the existence of black holes, although Einstein himself doubted that nature would actually produce such extreme objects. As observations improved throughout the 20th century, astronomers found overwhelming evidence that black holes are not only possible, but exist throughout the cosmos. The physics surrounding black holes becomes even stranger. Imagine falling toward one. To a distant observer, your motion would appear to slow dramatically, because gravity affects the flow of time. As the light leaving your body becomes increasingly stretched, you would appear to freeze near the event horizon and gradually fade from view. Yet, from your own perspective, time would continue normally, and you would cross the event horizon without noticing any special boundary. This remarkable effect is called gravitational time dilation, one of the most extraordinary predictions of Einstein's theory, and it has been confirmed through experiments involving gravity and time. Physicist Kip Thorne has explained that time dilation near a black hole is not simply a mathematical idea or metaphor. It represents the actual behavior of time itself. Gravity bends both space and time together, changing how clocks tick depending on their location in the gravitational field. But perhaps the greatest surprise is that black holes may not last forever. Physicist Stephen Hawking showed through theoretical calculations that black holes should slowly lose energy through a process now known as Hawking radiation. Over unimaginable lengths of time, they would gradually evaporate until they disappear completely. This leads to one of the biggest mysteries in modern physics. If a black hole eventually evaporates, what happens to all the information carried by everything that ever fell inside it? According to quantum physics, information should never truly vanish, yet black holes seem capable of destroying it. This puzzle is known as the information paradox and remains one of the greatest unsolved problems in science. Some of the world's leading physicists, including Hawking, Roger Penrose, Leonard Susskind, and Juan Maldacena, have spent decades exploring possible solutions, but no final answer has yet been accepted. For centuries, black holes remained invisible by definition because they emit no light. Then, in April 2019, scientists accomplished something extraordinary. By linking radio telescopes across the globe, they effectively created an Earth-sized telescope capable of observing a supermassive black hole located about 55 million light-years away. For the first time in human history, humanity captured an image of the glowing material surrounding a black hole. When the image was finally revealed, the scientific community celebrated a historic achievement. The glowing orange ring represented light being bent and distorted by the immense gravity of a black hole containing approximately 6.5 billion times the mass of our Sun. Rather than photographing the black hole itself, scientists captured the shadow it cast against the brilliant material orbiting around it. One of the key contributors to the imaging algorithm was computer scientist Katie Booman. whose work helped process the enormous amount of telescope data into the iconic image seen around the world. Her emotional reaction to seeing the result reflected years of dedication shared by an international team of researchers. Astronomer Andrea Ghez spent decades studying the center of our own Milky Way galaxy, carefully tracking the motion of stars that orbit an invisible object. Their astonishing speeds revealed the presence of a supermassive black hole at the galaxy's center. Long before humanity recognized its existence, our solar system had already been orbiting within a galaxy anchored by this enormous gravitational giant. Think about that for a moment. Every second, somewhere in the universe, a massive star reaches the end of its life, and somewhere a new black hole may be born. At this very moment, two black holes could be spiraling toward each other. When they collide, they release more energy in an instant than our sun will produce during its entire lifetime. The only evidence that reaches Earth is a tiny ripple in space-time called a gravitational wave, so incredibly small that our detectors measure changes smaller than the width of a proton. Humanity built instruments capable of detecting those whispers from across the universe. We looked into the darkest and most violent places in existence and chose not to look away. Instead, we built larger telescopes, better detectors, and more powerful theories to understand them. The universe still holds countless mysteries, and black holes remain one of its greatest. The deeper we explore them, the more they challenge everything we think we know about reality.